In this lesson, we're going to write a function that checks the user registration, and we're also going to write a function that registers the user. As always, we'll start off where we left off in the previous lesson using a git clone command. And don't forget to install the node dependencies before opening the project folder. Let's go directly into app.js. Let me update the header first. So the fifth step is to check the user registration. After that, we're going to call register user. Let's scroll down and start coding the check user registration function. I'm going to begin by using the exact same method I used in the getContractsProperty function to get an abstraction or a representation of our smart contract, which was called Chatway. Notice how I make a call to the check user registration function of the smart contract here. If the return value is true, that means the user is already registered. If the return value is false, that means the user has not registered. In this case, we're going to give the user the option to set up a new inbox. If the user accepts this option, we invoke the register user function. Otherwise, we return null. Let's also catch the error from our call to the smart contract. Before exiting, we're going to call another function called getMyInboxSize, and this will be a to-do. Now let's write the function for registering the user. As before, I'm first going to set up an object as a representation of our smart contract. And using that, I'm going to make a call to the register user function of our smart contract. Making a call to the register user function of the smart contract is going to cost the user some ether. So let's inform the user of how much ether they spent in making this call. I can do this using the receipt of the result coming from the smart contract. I'll use Web3 to translate from way to ether. Before leaving the function, don't forget to catch any errors. So that's it for the register user function. Let's quickly implement the getMyInboxSize function. We'll first make a call to the getMyInboxSize function of the smart contract. Here, I'll simply set a global variable to the output value of getMyInboxSize. Before exiting, I'm going to initialize the global variable at the top of my file. Let's save and exit. Now let's test our program. To do this, we're going to use a program called Ganache. Ganache is basically a visual representation of the test.rpc program we used in the previous lesson. You can download Ganache by going to the following website. I already have it installed, so I'm going to start it now. You can see that once the program starts, just like test.rpc, it creates 10 accounts. First thing you want to do is to go into settings and make sure the port number is 8545. In test.rpc, it's assumed that mining is done instantaneously. But to make it more realistic, we can change the mining time here. I'll set it to something like 2 seconds. We don't need 10 accounts, so I'm going to change the output to just give 2 accounts. After restarting Ganache, you can see that we have our 2 accounts. So let's go back to the terminal. Just like we did with test.rpc in the previous lessons, let's use our deploy to dev script to launch our smart contract. We'll go back into Ganache after launching the script. After a few seconds in the Transactions tab of Ganache, we should be able to see the transactions relating to the creation of the smart contracts. You can also see how the first account had to spend some Ether to create the smart contract. Now let's export the private keys for these 2 accounts into MetaMask. We now have our accounts, So let's run our dev server. We can easily verify the contract owner with Ganache. Now let me switch to the second user. If we refresh the page, you can see that the application is asking that user to set up an inbox, as we coded in app.js. If I click OK, MetaMask will pop up a window and ask us to submit the transaction. I can set the gas price to what I like, and the gas limit. Here I'll just set it to 10, and then I'll submit the transaction. If we come to the Transactions tab in Ganache, we can actually see the transaction that was made by MetaMask. Also, you can see the amount of gas that was used and the gas price. Coming back to our application, you can see that there's an alert window that says the personal inbox has been set up for this user. We can also verify the amount of gas that was spent, both in our application and in Ganache. If you had trouble following along, you can always download the final version of the code for this lesson using the git clone command you see highlighted on the screen. I look forward to talking to you in the next lesson.